What's up, everyone? My name is Maya, and I am a test prep tutor and academic coach at Bespoke Education here in New York City. At Bespoke Education, we offer remote and in-person one-on-one tutoring, classes, academic support, college essay coaching, college counseling, and mock testing. In today's mini lesson, I'm going to be walking you through a challenging problem from one of the College Board Practice SATs. This is a math problem from the calculator section of the SAT, so we will have our calculator handy. We may or may not need to use it. So let's jump right in. So we are going to be doing a problem out of the SAT Practice Test 6, which is one of the official College Board SAT practice tests that you can find on collegeboard.com. These tests are complete with answer keys and in-depth solutions, but we're going to be taking a really deep dive into one of the more challenging problems on the calculator math section of this test. So let's get to it. Today we're going to be looking at problem 27. So let's really quickly read the instructions. In the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? So we are told that this is the graph of a circle, but it's not in a very familiar form. Just a reminder that the formula for the graph of a circle in a coordinate plane is as follows, where h, k is the center of the circle, and r is the radius. So, with that in mind, how can we get this equation into this form to find r? Well, we have to do something called completing the square. Why do we complete the square? Well, we complete the square when we have quadratic expressions that we want to be able to collapse down to a single binomial squared. Let's look at the two terms with x in them from this equation, 2x squared and 6x. So quick reminder that we can write out a quadratic expression in the form ax squared plus bx plus c, where a, b, and c are all constants. Right now, before we complete the square, we want to make sure that a is 1, just to make our lives as easy as possible. And we can actually do that by factoring out a term that is shared by a and b here. We can factor out a 2. So let's pull out a 2. And again, we're still just dealing with the x terms. All right, so we factored out a 2, so our a term is 1. But we're not quite there yet. We're not ready for this quadratic expression to be able to collapse down into just one binomial squared. We need to add something. We need to add a constant. But what constant do we add? Well, here's how we can find what constant to add. We can take the b term, divide it by 2, and then square that. So in this case, our b term is negative 3. So let's divide that by 2, which would be negative 3 halves, and then square it, which would be positive 9 fourths. Now, you might be a little confused. We just added a constant. You can't just add a constant to one side of an equation. Well, you would be correct. We're going to be adding this constant to the other side of the equation as well. So fear not. So let's make a note of that. We are adding 9 fourths times 2 to the other side of the equal sign. We don't have to calculate it right away, just something to note. All right, now we can collapse this whole quadratic expression into a binomial squared. And what binomial is that? Well, we've got x minus 3 halves squared. And if you were to refoil that out, you would see that it would work. It would become x squared minus 3x plus 9 fourths. So that's our binomial squared. And we're one step closer to finding our radius because we're putting this expression into the standard circle formula expression. So now we're going to do the same thing with the y terms. So we've got 2y squared plus 2y. Again, they share a factor of 2, and we want our a term to be 1 just to make our lives easier, so let's factor out this 2. Y squared plus y. And now let's add the constant that will make this a square rootable, if you will, quadratic. So b, in this case, our b term is 1, b over 2 is 1/2, squared is 1/4. So positive 1/4. And that collapses down to, what is the binomial factor? Y plus 1/2 squared. And we got to make sure we add that to the other side of the equal sign as well. So what have we added? We added 1/4 in here, but it wasn't just 1/4. It was inside the parentheses multiplied by 2, so we actually added 1/2. So I'll just write it 1/4 times 2. We can do all our arithmetic all together. Okay, so now we have a really long equation, but that's okay. 2x minus 3/2 squared plus 2y plus 1/2 squared equals 45 plus 18/4. Let's reduce that as we go. 9/2 plus 1/2. We're almost there. Let's do everything on the right side of the equation. 45 plus 9/2 plus 1/2. 9/2 plus 1/2 is 10/2, which is just 5. And you can probably tell that we're getting really, really close to the answer. But don't jump to conclusions yet and decide, oh, it must be D, it must be root 50, because we still have these 2's here. And that prevents us from being fully in the standard form that we're looking for, x minus h squared plus y minus k squared equals r squared. We still have 2 as coefficients for each of these terms. So let's divide out a 2. Let's divide each term by 2. Divided by 2, divided by 2, and let's divide this side by 2 as well. And we are left with x minus 3/2 squared plus y plus 1/2 squared equals 25. So we're finally in that standard form that we were looking for, and we are ready to say with confidence that r squared must be 25, and therefore r must be 5. There's our answer. Thank you guys so much for watching today's mini lesson. If you like this video, please subscribe to our YouTube channel, and we'll be putting out lots more content just like this about the SAT, the ACT, and other academic topics. We also have some very exciting summer courses coming up here at Bespoke Education, both remote and in person. So if you're interested in those courses, including ACT and SAT foundations, a college essay workshop, and many more, please check out our website, bespokeeducation.com/classes. Please give us a call or email us at info@bespokeeducation.com if you are interested in setting up one-on-one tutoring or joining one of our SAT prep courses. And follow us on socials. The links will be in the comments below. Thanks again, and have a great day.